last unit. Here we go. Statistics. In the jar, there's 40 green, 32 yellow, 16 pink. Remember, the first thing is always total them up. 88. If you pick one, what's probably picking a green? Well, there's 40 green out of 88 marbles. What's probability you pick pink or yellow? Well, 32, 16, that's 48 total out of 88. Now, you pick two, one after the other, with replacing the first. So the probability of getting a green, we said, is 40 out of 88. If we put it back in, it's just like starting over again. And the probability of yellow is 32 out of 88. We multiply to find the chance of getting both in a row. 1280 over 7744. You pick three without replacing. So 3 pink in a row. Well, there's only 16 pink out of 88. If you don't replace it, now there's only 15 and there's only 87 in the bag. And then the third time, there's 14 pink left and then 86 in the bag. We multiply these. And we get 3360 out of 658,416. Not a really good chance. You roll a 6-sided die. What's the chance of getting a 5 or a 6? Well, that's two different numbers out of 6. What's probably you roll an odd number? Well, there's 3 odds. 3 out of 6. You have a regular 52-card deck. What's probably drawing a diamond or a club? Well, that's half the deck. That's 2 of the suits. You're going to order Jimmy John's. There are 2 breads, 3 meats, and 6 toppings. How many different sandwiches could you make? That's 2 times 3 times 6. Fundamental counting principle. 36 choices. How many different ways can you rearrange the letters in mathematics? Well, there are 11 letters. It's a permutation because the order of the letters matters. Every different order is a different word. So we use our handy-dandy calculator. And we first hit 11. Then you go to math, probability, and we're going to go to NPR. 11. That's a lot. 39,916,800 different made-up gobbledygook orders. Okay. Which pair of events is mutually exclusive? Well, Patty has a daughter. Patty can also have a son. Wow. Those do not rule each other out. You know what? It's possible to love math and reading. It's also possible to like apples and oranges. But it is not possible to get number 10 both correct and incorrect. One rules out the other, mutually exclusive. Identify the sampling space. Well, we use our funky braces. 1, 2, 3, 4, 5, 6. Recording the number of days in a week. Sunny days. Well, there's 7 days in a week. So you could have 1 sunny day, 2, 3, 4, 5, 6, 7. There's no way to get 8 sunny days in a week. Recording the number of snowy days in January. Well, I'm not going to make you write out all of them. So it's 1, 2, ... 30, 31. 31 days in January. Which cannot be a probability? Well, this one's okay. It's 0.75. 16 out of 55, don't know off the top of my head, but it is less than 1. 19 out of 15 cannot be. That is greater than 1. 0.08, that's fine. Okay, independent or dependent. The events of drawing two kings when two cards drawn from a deck and the first card is replaced. Well, if you pull out a king, you put the card back, it's a brand new deck. The first card does not affect the second card independent. Here we need to test A times B. 0.4 times 0.5 is 0.20, not 0.16, dependent. You're playing a lottery where you must match 5 numbers out of a total of 52 numbers. Order does not matter. So that's 52, C, 5. 52, math, PRB, NCR, 5. 2,598,960. The code you want to make has 4 digits in it. Remember, put the dashes in there. The first number cannot be 0, which means there's only 9 possible numbers here. But then there's 10, 10, and 10. You don't need a calculator. It's just 9,000. 1, 2, 3 zeros. And we're almost there. School year, 80 students tried out for football. Right there, that's the total. 65 made the team. 65 total made the team. 15 did not. 15 did not. Of the 65, 35 had played Little League, which means 30 did not. Of the 15 students that did not make the team, 8 had played Little League, which means 7 had not. We go across, that totals to 43 and 37, which does add up to 80. We're good to go. Based on the above table, answer the following questions. I'm not going to say reduce all fractions because you don't have to with statistics. What is the probability a person did not make the team? Did not make the team. Well, that's 15 out of 80. And remember, when it asks for probability, you need a denominator. If it just asks for the number, then it's just a number, no denominator. So probability of L given M. Remember, once you have the given statement or the line, that means put a box around it. And that's your new denominator. Now L is right here, 35. 35 out of 60, I can't live with that one. 35 out of 65. That's bad even for me. Okay, what's the probability of M and, no, sorry, not M and not L, or didn't make M, didn't make L. Okay? Well, let's look at that. Let's see. M prime. So the probability of, let's get this out of the way. The probability of M and L is right here. 7 out of 80. So that's probably both M not making the team and not playing Little League. Very rare. Now, the probability of not M, didn't make the team, or L, Little League. So didn't make the team is 15. Plus Little League, 43. Where do they overlap? Here. So we must subtract 8, which means 50 out of 80. And what's the probability of L apostrophe given M? So again, given M, I come here, and that's going to be 30 out of 65. And that is it for your review.